We will continue to our last presentation of today. That is given by Marco Valeri, and he speaks also for a group of people, for Pietro, Baldassarri, Silvano, Bertossa, Simone, Mantellini, Nicolò, Marchetti, and Valentina, Orrù. And the title of his paper is OrientGIS, Networked GIS in Archaeology, the cases of the Ebla Chora and Floodplains projects. Marco, please start your presentation.
Good afternoon. One moment. Okay. Can you see?
Yes, we can see. It looks good. Thank you.
Okay, perfect. So today I will show you two of our project focus on web application, mainly WebGIS, made with open sources to facilitate the sharing of the data between different researching groups and the world. Our first project we named Ebla Chora is in our portal OrientGIS, and you can visit by this link. We have other four projects in this portal: Islaie Valley, Samarkand, and Orient Dams. Ebla Chora, it will be quickly. Okay, sorry, it's not working. Okay, so the website is here. There are some references, some quick explanation of the project, but I will concentrate on the map on this web. This is a very simple WebGIS. So it's in a leaflet. Is basic coding, and there is a server named GeoServer where we put both raster and vectors data. As you can see, there is a table with the shapes file. All the shapes file are here. You can you can up the shapes file or the base map. You can choose OpenStreetMap, Esri, or others. There are also the raster like SMAP, topographic maps, or aerial photos, so on, other images. And a similar project is Samarkand, basically the same structure. So we have took the point from the survey, we have put on our GIS, on QGIS, and then we export the shapefile in GeoServer. GeoServer, with the coding in leaflet, will show us this result. And this is the, let's say, fixed project. So in here, it's mainly for a site or a survey area small. For a big area, less floodplains, Mesopotamia floodplains, we have a floodplains project. It's a WebGIS developed between 2018 and 2020, viewing and searching archaeological sites, both archaeological sites already identified by survey, by excavation, and then potential site located through remote sensing on the satellite imagery. The area of interest is the Mesopotamian alluvium area. The WebGIS development methodology consists of three main steps. One, the data collection. Two, the data evaluation. Three, the WebGIS development. It's a multidisciplinary team consisting of archaeologists, topographers, IT specialists, was involved in each step of the project. The project is coordinated by the University of Bologna in collaboration with the State Board of the Antiquities and Heritage, SBIH of Iraq, the Centro Ricerche Archeologiche e Scavi di Torino, CRUST, the Center of Ancient Middle Eastern Landscape, CAMEL, of the University of Chicago. Since this project was born from the collaboration of this and other different researching groups acting in different geographical and temporal areas, the preliminary phase consists in the standardization and the entering data to create a single automatic importation procedure of the data. They have been divided into different groups which accomplish different tasks. So now I will show you first in what we have done before and then how it works. So the first step was to research and collection the online topographic maps, satellite imagery of the entire area. In some cases, we have adjusted or georeferencing the maps. After the collected publication regarding surveying excavation in the Mesopotamia floodplain with particular attention to the maps. So basically, we have checked all the bibliography interesting. We took the maps, we scanned, we digitalized, and we use this with like a base for our project. Using all the base map collected, we divided the Mesopotamia floodplains in 4 regions. We are now talking about the remote sensing. We divide in 2 mainly, let's say, area: remote sensing and site, survey site or excavated site. Let's speak about remote sensing. Using all the base map collected, we divided the Mesopotamia floodplains in 4 regions. You can see in the different color. Basically following the main river and state border. So you can see Iran on the right, Iraq on the left. Each area was investigated by that person using satellite aerial imagery like Corona, Quickboard, SRTM, Aster, aerial photographics, and other, trying to identify every terrain anomaly that could be an archaeological site. Then, in a second moment, every anomaly was checked with more attention to delete those not relevant. The remaining anomaly is identified as a potential archaeological site where the limited contour using GIS software create a polygonal Esri shapefile. So this is an example of the first area. We located all these purple dots. There are potential and potential archaeological site. So we didn't have different about time or dimension. So we show you like 2 examples. These 2 in contour dot, in purple line. There are potential archaeological sites. And this is the result on the floodplains. Furthermore, for each anomaly identified as an archaeological site, we complied the attribute table with the info that you can see. So basically, there are the ID, so it's the name, it's the code for the name, that person is compiler. The district, Iran and Iraq are divided in district, let's say, province. The modern name of the site, if known, by, I don't know, Google Maps or by some other remote sensing. The ancient name, if known. If it is verified, if other person, other group are identifying the same anomaly like a site, if there is looting, bulldozer, structures, modern channel, natural damage, and remarks. You can see here, see also Corona, so this site is visible on the Corona. So we took an example. So this is verified, there is looting, no bulldozer, there are structures, modern channel, but not natural damage. See Corona for the remarks. This was an example. So this is in purple, are a possible site, but in the Bing Maps, they are impossible to see. You can see the other two, maybe three, but not this. But in the corona, it's clear that here there was a site, potential site, we don't know. Then we use for the second part of the floodplains, we try to identify georeferencing and digitalize all the sites present in the bibliography for the survey and excavation. For recognize the archaeological site already surveyed and or excavated, we took the publication between 1950 and 2019, provided geographic data to allow the georeferencing of other similar information useful for the project purpose. So other survey, there are not of our interest for some region, namely the impossibility of georeferencing the maps or lack of details. So it's not all the bibliography in the world, but it's the bibliography interested for us. At this point, we produce the survey area in order to allow calculation as the area as the perimeter, as well to identify the areas to be subjected to remote sensing. These shapes files were put on the GIS, where together with base map, satellite imagery, and area photos, were the base of our work. So we have base map, digitalized and georeferenced map, and shape file for the survey area. So this is the first step for the survey points site. So we have Adita Dam, Samarra, Mandali, land behind Baghdad, Akkad, Kish, land of Kufa, Nil and Nil Aratu, Bakarat, Cadiz, Farsu, Earthland of cities, Ur, Ammar Lake for the Iraq, Mainab, southwest Iran, Ras Hormuz for the Iran. So we have an example. This is Adam's maps for the Earthland of cities. We took a zoom in the map. You can see all the black dots with the number. We identify all the black dots in the real position with the base map of online base map, and we contour the polygon. For the remote sensing site, we have to fill attribute table, which for convenience we have made external to the shapefile. So the guys, the person who took the data, use Excel form, and then by the site, by the coding in the site, they are embedded in the shapefile of the floodplain. This is a little more complicated attribute table. So you can see the first page, second page. For example, we can put Tel Lame that we visited with the University of Bologna. It's basically like the first attribute table. The ID is the key of the database. Entry ID is the name that we, in the case of University of Bologna or the other surveys, place. It's the name of the site. The SBH number, the cadastre, is if the SBA, the SBH of Iraq, knows about the site and that number, have info about it. Modern name, Tel Lame, nearest city, the ancient name with the dots because we are not sure, the district, the governorate, and the nation. Then we have if there is remote sensing, if there is survey, excavation. Excavation 0 is excavation publication before our survey, and the remarks there are remaining to Cadiz survey project. There are the chronology, so there are the label for all the chronology. There are the documentation. There are the publication about it. The feature, the historical feature. So if we have found epigraphic finds, structures. There are the threats, modern threats. Also, there are the area of all the site, the maximum length and width, and the position, geographical position. So, like this is the example. This is the one dots. We'll zoom it. This is the tilde line. This is a base map online, Bing Maps. This is a corona. This is other images from satellite, like this. This is a orthophoto by a drone, so you can see the threats cultivation, the canals all around, looting with this area, with this hole in the terrain, and the structures. There are modern structures here, and here these are bank made by Saddam for the tank, for protected for the occupied. Some numbers. So we have signed 3,251 potential sites for remote sensing. So all the anomalies we have quite sure of 300 in 2031. Almost 5,000 archaeological sites from survey excavation, so the real archaeological site. We have 165,000 square kilometers surveyed through remote sensing, so almost the entire survey, or entire Mesopotamia alluvium. The 17 survey areas of 30 kilometers, 2 countries, Iran, Iraq, hundreds of gigabytes of satellite imagery processed, and dozens of publication files. So I will read this because I'm not IT, it's like Arabic for me. Talking about the structure about floodplains, the WebGIS is based on open source library. The geographic data are provided through a standard protocol, OCZ, Open Geographic Consortium, by a GeoServer instance, which is produced both raster and vector data. The raster data, for example, corona and or survey maps, are in WMTS format, Web Map Type Service. The images are broken down and provided in different map tiles according to the resolution to light and network traffic. To vector data, the polygon sheet file for the site or the service area, are in the UTSF format, Web Feature Service. The data are given to the client as a coded list of geometries with a tabular attributed link. The survey and remote sensing data are stored and managed within a Postgres SQL database, and it is equipped with the related PostGIS extension for the management of both potential data and not, through a shapefiles. This choice made it possible to optimize the archiving, breaking down the flat data provided by manufacturers into the several normalized tables, optimized according to reutilization criteria of the relationship database. In addition to a pure performance factor, the choice was functional for accessing the data through a second open source tool like Symfony application designed to proceed with a massive insertion and possibility the timeline modification of data through the interface. The user interface is entirely made with JavaScript using a popular framework named Vue and OpenLayers, one of the most used libraries for the development of offline maps. This user's interface is designed to be used through any web browser and it's possible to navigate the map and the turn levers on and off. The data is divided into information group, published, surveyed, and potential archaeological site, the Iraqi-Iranian administrative borders, the surveyor limits, original maps, 2 different corona sets, 2 different base maps. So now, how does the floodplains WebGIS works? Oh, this is the main view once you enter the site. You can choose which type of site to turn on and query. So there are sites, so the sites, survey, and remote sensing. Administrative boundaries, so you can choose nation or governorates or districts. Survey areas, we have line up all the survey area. You can choose one or two or three or I don't know. The base map, like I said, for the survey areas, you can hide one or two or three. Then we have topographic and satellite base map. In this case, is a digitalization of a base map in Wilkinson. You can use US Army map or various set of Corona. An online base map like Esri, OpenStreetMap, Bing Maps. You can choose aerial with labels or the classic road. So in the specific, for the survey, you can choose to open the attribute table of all sites, like this. You can choose here to show more of one single site, in this case Tel Meriaha, like this. You can see all the attribute table with all information in a specific way, with the information that I already told you in the tabular way. You can also export. This is very important. You can export in all this format, so basically shapefile and CSV. And you can filter and query about chronology. For example, there is a table of all the periods, like this, for example. You can choose to see only that site with that chronology, like this in tabular way, or you can choose to export. You can choose to zoom, like this. There are only the site you query. You can choose to check one site, like this. You can zoom in. You can make query about everything in the table. Remote sensing, it's basically the same with a less attribute table. Thank you for your attention.
Thank you very much, Marco, for your presentation, and thank you for keeping the time. I have already two questions from the public chat. I want to start with that. The first one is, thank you, Marco, for your presentation. It is really interesting. Would you please elaborate the data evaluation you mentioned in the methodology? Oh, your mic is out. We don't hear you. Can you turn your mic on? We can't hear you. I think you have to turn it on in the software.
Sorry.
Okay.
I click mute.
Okay. Did you understand the question?
No, sorry.
No, sorry. Okay, I read it again. All right. So thank you, Marco, for your presentation. It is really interesting. Would you please elaborate the data evaluation you mentioned in the methodology?
Yes, one of.
Hi, well, I'm one of the co-authors. Since Marco is more
Only the topographer.
Yeah, I took care mostly of this part, and I will reply to this question on his behalf. Well, basically, the validation consisted first of all during the remote sensing part in the cross-check, of course, of multiple data set, which are the ones that Marco just showed. But the most important part consisted in the ground truthing research. So most of the sites recognized through remote sensing were validated then in the field. Of course, not all of them, because we were dealing with thousands of sites. So we were forced to select a sample, let's say, of sites which were validated in the field during some of the survey projects that we, together with other teams from other partner universities, conducted between 2017 and 2020. So in total, several hundreds of sites have been validated in the field by means of state-of-the-art survey methodologies. So this is just to explain more in detail this part, which was not the main focus of the paper, but of course it was important to specify.
Thank you. We have already a follow-up question to that. As I know, aerial images for Iran, Corona and others, Iran have a serious gaps. So how did you evaluate data for Iran?
Well, in that case, of course, we used multiple platforms from the US GIS Earth Explorer, which provide probably the widest array of satellite imagery from the classified Corona until the latest Landsat 9 imagery, coupled with, for example, the Corona Atlas by Jessica Zana and the team of Arkansas University, the European Space Agency also, which includes, for example, the French spots satellite imagery. So in this way, we were able to provide a complete mosaics. It is true that, of course, we were not able to cover the entire Iranian area for each type of satellite imagery, because, of course, this is a matter of the single satellite mission. For Corona, for example, we were able to cover almost the entire area, but only, as far as I remember, only for a single mission. And from time to time, you also have issues related to visibility. For example, we in some cases you have clouds, which makes difficult to obtain a good satellite coverage, especially for the early periods.
Yes, and the Corona.
All right, thank you. We have actually a couple of questions in the chat, but we only have 3 minutes left, so I can probably read 2 of them, and maybe you can find a time later to answer the questions in the chat also, right? So the next question would be, thanks for the presentation, very interesting. Have you ever thought about using applications like ArcGIS 123 for this project as well?
Which application, sorry?
ArcGIS 123.
I don't know, because we are not the technician that code the program. So
you don't know, so you don't consider it.
No,
okay.
No, but we can provide the person who asked the question with the email of the ITs who developed the. Well, we are actually working on a paper also to with aim to better explain the entire methodology of our project. So I mean, it will be better, of course, for the person who asked the question to get in touch with our IT personally. But if they have some patience, let's say, they can wait till our research is published.
Okay, thank you. Then I will ask one last question. Thank you, Marco, for your very interesting presentation. I probably missed this information, but is this web GIS already online?
Not yet.
Okay, not yet. But can you expect?
Soon we will be ready.
Yeah.
Yes.
Sounds like expectations from Microsoft or Apple. They all.
We are not that big.
No.
Although we try, of course.
Okay, thank you both very much for answering the question. I'm very sorry that the last question did not get asked here, but maybe you can find the time to answer it in the chat. To honor the time